Alrighty, so in this video, we're gonna go over page number 3 of exam number 4, parts A and B, in relation to finding antiderivatives. And in this case, we're asked to find two definite integrals. So we have, for part A, starting, we have integral 1 to 16 of 4 minus 1 over x plus 3 over 2 root x dx. So starting off with that, so how do we approach this kind of problem that has definite integrals? So in this case, what we want to do first is we want to find the integral of this expression. So how do we do this? So finding the antiderivative. So antiderivative of 4 is just simply 4x, because we're just undoing the derivative. And then 1 over x is just ln of x. And then now, in this case, we have 3 over 2 root of x. So what I like to do, to simplify this process, is rewrite this in terms of the power rule. So we have 3 over 2 x to the power of negative 1/2. So if we apply the power rule, now we have 3 over 2 x to the power of 1/2 over half. So this is what we have right here in this case. So given that we have two fractions, we can just apply the copy dot flip. So we have 3 over 2 times 2 over 1, which equals 6 over 2, which just equals 3 in this case. So this expression will just lead to 3 root x. So we can just rewrite this as 3 times root of x. So now that we have the antiderivative, what we want to do is we want to apply the f of b minus f of a rule in order to find the definite integral, or find it in the evaluated manner, because when it comes to the integrals, this represents a, this number on the bottom, and then the number on the top represents b. So how do we do this? So we want to plug in 1 for a, plug it into the antiderivative, or plug it into the antiderivative, and do the same thing with 16, but plug it for b into the antiderivative and find the difference between the two. So let's do this together, shall we? So let's start off with f of b. So in this case, we'd have 4 times 16 minus ln of 16 plus 3 root square root of 16 minus f of a, which in this case would just be 4 times 1 minus ln of 1 plus 3 root 1. So it could just be like this. So now we must simplify this expression and find the final answer. So in this case, 4 times 16, that's just 64 in this case. Just write the parentheses. Ln of 16 just remains ln of 16 plus 3 times 4 minus 4, and then ln of 1 would just result in 0, plus 3, because root 1 is just root 1. So now we have 64 minus ln of 16 plus 12 minus 4, because you want to bring this negative into, distribute it evenly into the expression. So we distribute it accordingly. So we have minus 4 plus 0 minus 3. So now combining those terms together, so we have 64 plus 12 minus 4, that gives us 72. Then minus 3, that gives us 69. So we just have 69 minus ln of 16 as the final answer for this problem set. And then for b, in this case, we have another definite integral, but this time we have the definite integral of 0 to square root of pi over 3 of x sine x squared over cosine of x squared dx. So in this case, as we mentioned before, we want to utilize u sub in order to find the inside function in this case. So what do we want to do? So the inside function, to enable us to solve this problem most easily, we want to find an inside function that could help us cancel this out in terms of the derivative. So in this case, cosine would be a perfect fit for that. So we could just say u equals cosine x squared. So now we got to find the derivative. So du is negative sine x squared times 2x, because we want to apply the chain rule. So we want to find the derivative of the trig. We also want to find the derivative of the inside function in this case. So dx. And then dx in this case would just equal du over negative 2x sine x squared. So now we want to rewrite this into the integral. But before we want to do that, we also want to plug these two points into the u in order to determine whether or not the integral needs some sort of alteration, or to make sure that we have the correct values when it comes to the interval a to b. So in this case, we just do u of 0, which is just cosine of 0, which just equals 1 in this case. And then we do u of root pi over 3, which equals cosine of root pi over 3 squared, which equals essentially cosine of pi over 3, which in this case would just equal 1/2. So now that we have these two, we can just rewrite this as 1 of the integral of 1 to 1/2, and then x sine x squared over u, and then plugging in the dx, we just have du over negative 2x sine x squared right here. So how should we do this? So we can instantly cancel out the signs, then we can cancel out the x's as well too. So essentially we'd have the integral 1 over 1 to 1/2, and then we'd have negative 1/2 times or we just have in this case negative 1/2 times 1 over u. So what should we do over here? So in this case, we can just take this negative 1/2 outside of the integral because it's a constant. So in this case, we'll just do negative 1/2, and then 1 to 1/2, and then we do 1 over u du, just like that. However, the problem is, given that the interval of an integral starts from a to b, a has to be the smallest number and b has to be the bigger number. So in this case, our a is 1 and our b is 1/2, which doesn't make any sense because we're just going in the opposite direction where we're supposed to have an increasing interval. So in this case, we have to flip the integral, which in this case would lead us to have a positive 1/2, integral 1/2 to 1 of 1 over u du, in this case, just like that. So now that we already have that in, what we want to do is find the integral of this, which will just give us, in this case, we'd have 1/2 times ln of u so that would equal the integral. And then now that we have the new integral, within the integral, we want to apply the same rule of f of b minus f of a in order to find the final solution. So in this case, we have ln of 1 minus ln of 1/2 over 2, because you can just multiply these two together, which will just like result in ln of u over 2. So now that we have this, so ln of 1 is just 0, so we'd have ln of 1/2 over 2 as the final answer for this expression as well too. So that's it for this problem set right here.